Hi, everyone. Thanks for joining us today for our Explore the Kinematics of a Cart on a Ramp webinar. So we have Tom Smith as your main presenter. He has 9 years of teaching experience in high school physics and engineering classrooms, and he has been with Vernier for 7 years. And we also have Dave Vernier, our co-president and co-founder. He has 12 years of teaching experience with high school physics and physical science, and this is our 40th anniversary of Vernier, so he has 40 years at Vernier. So I will pass it on to Tom and Dave.
Okay, thanks, Angie. And thank you all for joining us with this webinar, taking some time out of your summer to even begin to think about next year. My hat's off to you. So thanks for being here. And thanks, Dave, for being both my student and my lab assistant in this webinar. That's great. So we're going to go through a lab called Cart on a Ramp. It's lab 3 in our Physics with Vernier book. And when I was teaching in a physics classroom, this was typically maybe the 3rd day of class or something like that. The first day I would spend just getting to know my students. The next day we might be getting used to some of the technology and equipment that I had in my classroom, maybe do a graph matching activity, and then we would start to explore kinematics, and specifically the constant acceleration model. We're going to use graphical analysis as our data collection tool, and we're going to use a couple of the tools that are featured. So the first one is going to be data sharing. So with Graphical Analysis Pro data sharing, you're able to stream data to your students real time. And so if you're doing a demonstration in front of your classroom, you can stream that data to your students on their own devices, whether it's a computer, a Chromebook, or their smartphones. And also gives you an opportunity, heaven forbid we get back into a pandemic situation where you're teaching remotely, you can be showing video of yourself collecting data in your classroom while your students are getting that data on their devices, as long as they have an internet connection. The other tool that we're going to show at the end of the webinar is some of the embedded experiment files that have both data that we have collected in the lab, as well as synchronized video with that. And I'll show you some of the benefits of that particular situation. But if you have graphical analysis installed on your computer now, we can use this code to go ahead and activate the pro versions. Let me back up just 1 second, and I'm going to show you how you can download graphical analysis, the free version, if you don't already have that. So here I am on Vernier.com, just at the home page. And then if you go to the downloads tab here, you can click on that. So again, this is graphical analysis. There are versions for Mac and Windows computers. You can download those directly from the website there, or there are links to the appropriate web stores if you have an iOS device or an Android phone or a Chromebook. You can access those there, and the download should happen pretty quick, and then we can activate the pro version here while we're talking. So I'll get that out of the way. Okay, so if you have graphical analysis open, you can, Angie, if you haven't done it already, would you capture that code and put it in the chat? It sounds like that's been done. And let me go to the next screen and kind of show you how this might work. So let's see, get that up there. So this is my student Dave's device there. And then here is my version of graphical analysis. Now, in I'm going to just set up a sensor data collection system session. And Dave, if I could get you to turn on the sensor cart that we're going to use for this experiment, then I'll have a device to connect to. So there's the sensor cart. I'll just click on that, connect to it. And then sensor channels. I'll just show this to you. We're going to stay on position because that's what we're interested in. Cart on a ramp. We'll just look at the position, velocity, and acceleration graphs associated with that. There are other channels available, but we're just going to stick with position. And I can hit done. And I'll note that, close that out. And you'll see that by default, we just get position and velocity versus time graphs. We're probably going to find it's most useful to throw a third graph up there. So I'm going to come up here to this little view options icon. And instead of 2 graphs, I'm going to select 3 graphs. And there we get position, velocity, and acceleration. All this is getting a little bit scrunched together because I'm splitting my screen with Dave, but you can hopefully see that on your own devices or look closely at your computer screens as you're watching this. So these just automatically generate like this. And in order to, we're going to start a data sharing session now so that Dave can get the data that I'm going to collect as I'm collecting it. So I'm going to click here, start a data sharing session, and you'll see this code, SFM0NR. I can make that a little bigger, kind of handy. And once again, Angie, if you would grab that and put it in the chat, that'd be great. Now, Dave is starting a new experiment, and he's choosing data sharing. Can you go back and show that again real quick, Dave, so you can show people where to connect. So he's clicking on Untitled, clicking New Experiment, and then Data Sharing is the option he chose. And then he's going to specify this code for local data sharing.
So Tom, while Dave's connecting, we do have a couple of questions that maybe you can go over.
Sure.
One is the data sharing only on the pro version of GA or graphical analysis?
Yes, so let me just jump in and answer that. So that is one of the key features of the Graphical Analysis Pro version. And the Pro version is a subscription service. There's an annual fee for school to sign up for that. And that's that. And there's a couple of other key features, one of which we're going to see at the end of the webinar. And then continuing to build additional resources into the Pro version as well. Other questions there?
So Sylvia wants to know, do students at home, do they just type it into their URL address bar?
So they would open up graphical analysis. So they'd have to download graphical analysis onto their device. And then once you've started your data sharing session, they would, just like Dave was trying to do, go to New Experiment and then type in or go to data sharing and type in that code.
Just one more question, Tom.
Sure.
So there was a little confusion on the graphical analysis pro temporary code versus the data sharing code and when you put each of those in. If you can explain that a little bit more.
Yeah, so the temporary code is just to give us access for this webinar for a couple of weeks. And that happens when you first launch graphical analysis. So if you have graphical analysis installed on your computer and you go to launch graphical analysis, it'll have a place for you to enter that code. Oh, Dave, if you go back to the very beginning
Yes.
of that and hit Untitled
Yes.
and New Experiment, notice that we haven't authorized GA Pro here. So let's go, let me see if I can find the chat.
Yep.
Capital U, capital, oops, capital U. There we go. Capital M, capital M, capital H. There we go. And small case PIS, capital D, capital G. That would explain
Okay,
why
sorry
we
about
were
that.
having trouble with that. Yeah, great. So everybody learned something there. And now that code that we're looking for is this code right here. So hopefully this helped answer that last question about which code to use when. Once you have a purchased version of Graphical Analysis Pro, you shouldn't have to worry about that code ever again. It would just be a matter of the data sharing code when you're data sharing with your class. I think that was a very instructive segue for okay, so here we go. Again, cart on a ramp. I'm going to show a video camera here briefly to show you what our experimental setup looks like. We have a cart on a ramp. Simple enough. This happens to be a sensor cart, and that sensor cart, it has the motion encoder built into it. Basically, you could do this experiment with other hardware. So I could use a motion detector. Thanks, Dave. And just put it on the end of the track like that to capture the motion. But we wanted to use the sensor cart. It just gives really clean data, very effective way of collecting data for this lab. Do you want to, Dave, you want to roll it up the cart, up the ramp just to show us? So typically you're going to roll it up and then catch it before it hits the backstop there for the first part. And the lab starts with, let me bring these back up here quickly. Having the students make a prediction as to what that graph is going to look like for the position versus time graph, for the velocity versus time graph, and for the acceleration versus time graph. So Dave's going to go ahead and do that. I'll point out as he's doing it that for the position versus time graph, he's going to click on this graph tools button. And you'll notice when he does that, that the entire screen opens up to look at just that position versus time graph. And we'll look at position. And, oh, sorry, I did something backwards there.
Want me to draw my prediction, huh?
Yeah, I want you to draw your
I got to
prediction.
think about this. It's getting farther away. And then it's coming back, I think.
Okay, so Dave is being a model student for us, so don't judge him too harshly. But that would be, at this point, if he talks to his lab partners and they decide that's what that prediction is going to look like, he can just hit the save button. And that becomes basically an image on his prediction screen. Now, if you would pull up your velocity versus time graph at this point, we can create a, oh, interesting. I'm going to go back myself and pick 3 graphs so that I can see all 3 of these at the same time. Seem to have some challenges clicking for some reason. There we go. Okay, so we're going to do that for a velocity versus time graph and for an acceleration versus time graph, making predictions for each one of these.
You want me to do a draw my velocity prediction?
Yeah, why don't we go ahead and do a prediction for the for velocity?
I think it's going to see it's starting slow. This, oh wait, it's starting slow. Which I guess it's going to slow down again. And I guess it's almost like that. No.
Okay, so if that's your prediction, you can hit the save button. Now, we have two predictions here. It might be worthwhile naming them separately. So you could say prediction velocity or prediction. So let's go to, I think if you click on the axis, you should be able to click on your
This one here?
prediction
Rename it,
and
huh?
rename your prediction.
Okay.
Oops. And you can imagine doing the same thing for acceleration, just to kind of keep the ball moving here. Why don't we pull up your prediction for position on the top graph and for velocity on the next graph. And I think our viewers get the idea of that. And we'll go ahead and collect some data. The lab has us let the cart sit for about a second, and then launch it up the ramp, and then catch it on the way back down. So we'll get a set of data here. And I'll go ahead and collect, and you can start when you're ready, Dave. And you can see the data coming in on the velocity, position, and acceleration graphs. And they should stream in on Dave's graph as well.
Oh,
so
I didn't do very well.
So this is a great opportunity for the students, either individually or as lab groups, to get together and consider what was different about their prediction, what they did right, what they need to revise their preconception about what the graph is going to look like. You can also challenge the students to become more sophisticated in their predictions. You can say, okay, how far up the ramp is it actually going to go? So instead of drawing to 1.4 meters, when your ramp is actually only 1.2 meters long, that might be
Are
a
you
clue.
saying that wasn't very smart of me? Huh?
I would never say that, Dave. But those types of discussions, I think, are very helpful before we actually get into collecting the data and then doing some analysis. At this point, the lab would have students, this is part one of the lab, and the instructions would say, go to the analysis part of part one. Now, part of that is to mark on the graph particular elements, like where the graph is, and maybe I'll just blow up my screen here a little bit so I can demonstrate this a little bit closer. So mark on the graph the highest point of motion, and so we can kind of pinpoint that here, and note that it coincides with a velocity of 0. So that the cart actually stops at the very top. And then looking at our acceleration at that same point, we can note that, wow, that acceleration is really pretty constant the entire time the cart is in free motion. So there's a lot to kind of unpack here with the analysis questions. They also ask you to consider the portion of the graph that is where it is going up the ramp, and mark the portion of the graph where that's going down the ramp, and look at each of these sections of the other corresponding graphs. And then finally, it introduces the constant acceleration model and explains just in really kind of factual terms, the idea of so creating a curve fit. So let me change my view here ever so briefly. Just go to one graph. I'm going to do a curve fit for the position versus time graph. So add a curve fit. and the instructions tell students to use a quadratic and to apply that. And then they get this form for their equation. They can note these parameters that create that equation and match that up with the x is equal to 1/2 times the acceleration squared plus the initial velocity times the time plus a constant c. So they can go through that constant acceleration model. And they would do basically the same thing for each of these three, using the slope of the velocity graph for acceleration for the velocity, and then the average value of the acceleration during this portion here. And they would use the statistics to get to that average acceleration. Now, note that I've done a lot of analysis here on my particular graph. I'm going to come back here, and if you look at Dave's screen, he doesn't have any of that analysis data that I've done. So he's really forced to do the experiment himself. The data sharing does not provide curve fitting to transfer, it just transfers the data, which is a real nice benefit to encourage everybody to engage with the experiment.
Hey, Tom.
Yes.
There's a question that I think is relevant for right now. Mary wants to know, how do you save the graph or experiment and then pull them back up? Where do you save them on your computer?
Oh, okay. Well, personally, I like to save my my graphical analysis files on a Google Drive. So I just come here and I can say save as, and it's going to give me an option of where to save it. I can, I'll just save it to my desktop for this particular example. I just have to select my desktop, and then I'll just say it's test 1, and I can save that. Now, if I want to find this again, I can come here to new experiment, and instead of, I can choose a file instead of that. I go to my desktop, I find test 1, and I can reopen that. And there, it's kind of odd to open a file that I just opened, but, or just saved, but there it is. That's how you would do that. You can also, if you save it to a Google Drive, you can also share that with classmates or with your teacher, depending on how you hand things in. So I do recognize, and we just have a few minutes left, I want to show briefly the ability to use the embedded experiment file. So I'm going to show my entire screen again. And I'm going to start a new experiment. I won't save this time. And when I start a new experiment, I have this sample experiments. I can see my experiments. I know that we're doing a physics experiment. So I can either go by subject or I can go by lab book. This happens to be in physics with Vernier, so I'll use that filter. And we're looking at cart on a ramp. So I'm going to open up this particular experiment. Now you'll notice these files are going to look very similar. We have this parabolic shape here for position versus time and the straight line for velocity versus time. But we also have this video embedded with the data. So I can just play that video so it shows what the experiment looks like. But even better yet, let me minimize this a little bit. I can use this replay button. So enable replay. And if we go to, it brings up these tools right here. I can hit the play button and you'll see that we have data coming in. We have a video that's synchronized with that data, which is really kind of handy, especially if you have a student that's absent. maybe they're making up work remotely or one of those situations. But there's also some nice features that you can slow this down. So if I slow it down to basically a third speed here, I can really zoom in on what's going on with the experiment. So we, again, slowly going up here. I can pause the video at the top and really realize that, okay, my velocity is really 0 right here. And I can move the video backwards and forwards off of that as well. So to be able to slow the video down in physics is a really nice thing. In biology, you might want to speed it up because you don't want to watch plants grow really slowly. So, and that shows some of the features of this particular application.
Hey, Tom, while you're on this screen, we had a question about, could you add the acceleration graph to this one as well?
Yeah. So let me just go again to this view icon, and I can choose 3 graphs. And acceleration is going to show up by default. If I wanted a different parameter showing up on my y-axis, I can just click here, and I could choose velocity, position, any of the 3 or all 3 if I wanted to. We'll leave it with acceleration for now.
And then we had a question, is the video experiment portion only available in the Pro version?
Yes, again, this is one of the Pro version features. The other kind of major Pro version feature that you'll find is your ability to take video of experiments yourself, embed them with your, so if I come up here, you'll notice that there's a video option. You can embed a video of your own making and synchronize it with the data that you've collected using sensors. So those are probably the 3 main features of Graphical Analysis Pro, although there are others.
And yeah, I think you just answered this other question, is how do you sync the video to the data?
I'm answering here.
Okay, it sounds like Dave's trying to get to that in chat. There is, without having a video at hand to kind of show how that works. Let me see if in these experiment files, there's actually this button here. You can change the times depending on the time of the video versus the time of the data and match those up. In fact, you may want to see if this is really the best synchronization. You may adjust that slightly and see how that works. Angie, how are we doing for time and questions?
We are at time, just a few minutes over. And I will say that we have Julia, I'll follow up with your question after the session today. I just need to do a little research on looking at what you've purchased before. But I think that all of the questions other than that one have been answered.
Okay, well, I just want to thank you once again for tuning in to the webinar, and enjoy your summer and good luck as you start school in the fall. Again, appreciate your attention this morning.